Okay, so this is Dane's strength, and I had chapter 10, scatter plots and correlation. Okay, the problem I did was on NFL concussion statistics from the last 7 years. The problem reads, a sample was taken of the number of concussions received in the NFL from players who play running back and linebacker over the course of the last 7 years. Based on the data, can it be concluded there is a significant linear relationship between the two? And the alpha is 0.05, so our hypothesis will be P equals O, and our alternative hypothesis will be P does not equal O. Okay, so here you can see the data for the running backs concussions in the last 7 years and the linebackers in the last 7 years. So if you go to Stats List Editor on your calculator, you can enter in the running back data as list 1 and the linebacker data as list 2. So the next thing we want to do is solve for R and R squared. To do this, first thing you do is hit F4 on your calculator. Then next you hit regressions, which would be the third one down. After that, you select the first option, which should be linreg, and the equation next to it should be a plus bx, and then you will enter your data, which is basically just making sure that next to x is list 1 and next to y is list 2. Okay, so now you should have solved for r and r squared. R should equal 0.906 and r squared should equal 0.821. The next thing you want to do is solve for critical value. For that, from the stats list editor page, you'll hit inverse t and then you'll enter in 0.025 and then you will enter in the degrees of freedom, which should be 5, and that will give you your critical value, which will be negative 2.571. Okay, so the next thing you want to solve for is the test value. To find test value in these types of problems, you're going to do the equation R equals square root of n minus 2 over 1 minus r squared. So in this case, we already solved for r. We figured out it was 0.906. We're going to subtract it by the square root of n, which is 7 minus 2, which is just the degrees of freedom. And underneath it, you'll have 1 minus r squared, which we discovered was 0.821. And that'll all come out to equal 4.788. So 4.788 will be your test value. Okay, so now that you know the test value is 4.788 and the critical value is negative 2.571, you can graph this problem, and it should look something like this. The 0 in the middle, on one side you have the critical value, negative 2.571. On the other side you have the critical value again, and you shade these in just so you can show. And to the right you will have your test value of 4.788. So that test value falling in the shaded region will give you reason to reject your original hypothesis. Okay, so as we saw on the last slide, you can see that the test value does fall outside of the non-shaded area, giving us reason to reject. So the next thing you want to do is make a statement, and our statement should be, for this problem, reject And our reasoning is we can claim there is a linear correlation between the number of concussions between running backs and linebackers. See if I can get this so you guys can read it. There you go. Alright, so you can see in this scattered plot of the data here that there is a positive linear relationship. You could tell by the way you can draw a line of best fit that'll be stretching from the lower left to the upper right. So you can see that there are an increase in concussions in the past 7 years leading up to today. Okay, so the final part of this process would be an approximation problem. So there is a formula for the relationship of concussions between running backs and linebackers, and it's y1 equals a plus bx. So now you can solve problems such as, so if a running back has 26 concussions, how many will a linebacker have? To figure out A and B, you'll go back to how you solved for R and R squared. You'll enter the data for list 1 and list 2, and then you'll go to regressions. And once you enter it, if you scroll down, you'll see, once you see the R and R squared, there is an equation for A and B. And so A and B, in the case of the problem we just solved, A would be 7.218 and B would be 0.525. So if you did the equation, y1 would be 7.218 plus 0.525 times 26, and if you work that out, it would end up being 20.868. So you can assume if a running back has 26 concussions, a linebacker will most likely have around 20 or 21. Okay, that's it. Thanks for listening.